First of all, I welcome all the students and the participants who are attending this live lecture. So in this today's live lecture, we shall discuss the examples based on the inverse Laplace transformation. Examples based on inverse Laplace transformation. Yes, Sandesh? So in this example, we have to discuss yesterday due to the problem of light, we have disconnected in the middle of our lecture. So we shall continue yesterday's lecture, and in that addition we shall see the examples based on this. Okay, now here examples on inverse Laplace transformation. Yesterday we have seen some examples. Now today we shall continue the examples based on this, that is examples on inverse Laplace transformation. 1 minute. That is inverse Laplace transform and example based on this. This is the definition of inverse Laplace transform. Means L of f of t is equals to capital F of p is equals to integral from 0 to, okay, this is the definition of the inverse Laplace transform. If the Laplace transform of small f of t is a capital F of p, then small f of t is called as a inverse Laplace transform of capital F of p. Okay, so L of f of t is equals to capital F of p, then we can write L inverse of f of p, which is equals to small f of t. Okay, now these are the corresponding formulae regarding Laplace transform and inverse Laplace transform. That means here Laplace transform of 1 is 1 upon p, so Laplace transform L inverse of 1 upon p is equals to 1. L of e raised to a t is equals to 1 upon p minus a, then L inverse of 1 upon p minus a is equals to e raised to a t. Okay, so thus we get the result. Now these are the linearity properties. First translation of first shifting, second shifting property. In this way we can continuously see the examples based on this. Now methods of partial fractions. Methods of partial fractions. Actually, yesterday we have seen the problems based on the partial fractions. Means we have to separate the denominator, product of denominator in the addition and subtraction form. So there are different types of partial fractions. You must know how we can convert the given function into its partial fraction. See this, if 1 upon x minus a into x minus b are linear term divided by x minus a upon x minus b, then its partial fraction we can write, because there are two brackets, two factors in the denominator. So partial fraction we can make by using two constants a and b, such that a divided by x minus a plus b divided by x minus b. Suppose second function is of the type px square plus qx plus r divided by x minus a into x minus b into x minus c into x minus a. Actually there are three brackets in the product, in the denominator, in the product form. Then we need three constants a, b, c for its partial fraction. A upon x minus a plus b upon x minus b plus c upon x minus c. Actually there is the partial fraction is independent on numerator, but it is essential that degree of numerator must be less than degree of denominator. Then only we can take the partial fraction. If degree of numerator is greater than degree of denominator, then first of all we have to divide, and then after division we have to convert the function in such a way that degree of numerator must be less than the degree of denominator, and then we can use the partial fraction. So the numerator whatever may be, but it is essential that its degree must be less than denominator, then we can use the partial fraction. Next, third type of partial fraction is, suppose px square plus qx plus r divided by x minus a into x minus b bracket square. Here also there are three terms in the denominator. First is x minus a, second is x minus b, third is again x minus b, because x minus b bracket square means there are actually three terms in the product form. So again we need three constants a, b, c, such that if here in this case x minus b is a repeated term, x minus b is a repeated bracket, so its partial fraction is in this way: a divided by x minus a plus b divided by x minus b plus c divided by x minus b bracket square. If there is a bracket cube, then we have to use four constant a, b, c, d. In this way we can take the partial fraction. If there are three brackets x minus a bracket cube, there are three brackets in the denominator which are repeated, so its partial fraction we can write a divided by x minus a plus b divided by x minus a square plus c divided by x minus a bracket cube. Next, fifth, px square plus qx plus c divided by x minus a into x square minus b. So a divided by x minus a plus bx plus c divided by x square minus b. Now we shall move towards the problems based on the inverse Laplace transform. Now see here, 1 minute. Okay, the problem number 14, that is L inverse of 2 divided by p plus 1 into p square plus 1. See this here, the actually first factor is linear term, second factor is a quadratic term. If there is a linear into quadratic, then we have to use a partial fraction as like a fifth term. Linear into quadratic, first denominator is linear, second factor is quadratic x square minus b. If linear into quadratic, then its partial fraction we have to take in such a way that a divided by x minus a, and if the denominator is quadratic, then its corresponding numerator we have to take bx plus c. So all these rules you must know to take the partial fraction of the function. So we can write this. Yes, okay. Now by the partial fraction 2 divided by p plus 1 into p square plus 1, its partial fraction is a divided by p plus 1 plus, again second denominator is a quadratic term, so bp plus c divided by p square plus 1. So we have to, this is a quadratic factor, so we have to take its numerator as a bp plus c with two constants bp plus c. Now again by taking the LCM on the right side, a into p square plus 1, again cross multiplication bp plus c into p plus 1, this is a LCM, and in the LCM there is a multiplication of the denominator, and this denominator will be reduced. So our next term will be 2 is equals to a into p square plus 1 plus bp plus c into p plus 1. Now our aim is to find out the value of a. So we have to reduce this bracket, total term goes to 0. We have to convert this total term into 0 by putting p is equals to minus 1. So minus 1 plus 1, this bracket goes to 0, 0 into this term means total term goes to 0. So by putting p is equals to minus 1, we can find the value of a. So put p is equals to minus 1 in equation 2, therefore a will be 1. A will be 1. Again, if we put p is equals to 0, then what will happen? Then b goes to 0. We have already calculated a. Then by using this value of a, b converts into 0 and we can find the value of c. So if we put p is equals to 0, then what will happen? In equation 2, 2 is equals to a into 1 plus b into 0 plus c into p plus 1 means again p. So this goes to 0. Put the value of a is 1, which we have already calculated. So 2 into 1 plus c. Okay. So we can write this as a 2 is equals to 1 into 1 plus c, c is equals to 1. Now in this way we have substituted p is equals to minus 1, p is equals to 0. So P is equals to, by using P is equals to minus 1, we have calculated A. By using P is equals to 0, we calculated C. Now our aim is to find out the value of B. Now to obtain the value of B, there is only two brackets, two terms. So you have to put any value of P. You can take any smallest value of P. So here we have considered P is equals to 1. Put in equation 2. If we put P is equals to 1 in equation 2, then what will happen? 2 is equals to A into 2 plus B into 1 plus C into 2. So 2 is equals to 1 into 2 plus B plus 1 into 2. So we can write 2 is equals to 2 plus 2B plus 2. So these two will be get cancelled. Therefore 2B is equals to minus 2, therefore B is equals to minus 1. In this way, we have calculated value of A, B, C. Now put this value of A here, B here and C here. A is 1, B is again, B is 1, B is what? B is minus 1 and C is also 1. So B is equals to minus 1 we have to put, C is 1 we have to put. Then we can write this partial fraction in such a way that, how we can write this partial fraction? So 2 divided by P plus 1 into P square plus 1, which is equals to L inverse of, now you can write the partial fraction of this. A means 1 divided by P plus 1. So this bracket will be 1 divided by P plus 1 plus minus P plus 1 divided by P square plus 1. After putting the values of A, B, C, our partial fraction is in this way. Now you have to separate this. Separate this L inverse for 1 upon P plus 1. Again separate this L inverse for minus P divided by P plus 1. Again we have to separate this L inverse for 1 divided by P square plus 1. So there are three terms we can separate with separating the denominator in the second factor. या second factor मध्ये denominator जो आहे ना तो separate करा numerator सोबत. Okay, so we'll get the three terms and we can obtain the inverse Laplace transformation for these two simple terms. So L inverse of 1 upon P plus 1 is equals to e raised to minus t. L inverse of P divided by P square plus 1 is equals to cos t, and L inverse of P square plus 1 is equals to sin t. Okay, in this way we can obtain the solution of the function. Now we shall move towards find L inverse of P plus 1 divided by P square into P plus 2 bracket raised to 5. Now student, you tell me, you have to convert this denominator into the partial fraction. How many factors are there in the denominator, students? Now you tell me how many factors are there in the denominator. P square means there are 2 factors. Again P plus 2 bracket cube म्हणजे there are again 3 factors. P plus 2 bracket cube means it has 3 times. P square means P into P, it has 2 times. Therefore, there are 5 linear factors. Okay, barabar hai Silpa Panchad, very good. There are 5 linear factors. So we have to write its partial fraction by using 5 constants A, B, C, D, E. But here P square is a repeated factor of linear term, that is P into P. P plus 2 is again repeated factor. So its partial fraction we have to write in this way. A divided by P plus B divided by P square plus these two are for repeated factors of P. And next 3 are for the repeated factors of P plus 2 bracket cube. So C divided by P plus 2, D divided by P plus 2 bracket square plus E divided by P plus 2 bracket cube. See this. This is also one important example. Again, this is also important example. So you must understand all these concepts regarding this. 1 minute. So we can write this. Its partial fraction will be A divided by P plus B divided by P square plus C divided by P plus 2 plus D divided by P plus 2 bracket square plus E divided by P plus 2 bracket cube. Do you understand this method of a partial fraction? Students, ये समझ में आता है क्या? पार्शियल फ्रैक्शन कैसा होता है, किस तरह से करना होता है, ये समझ में आता है क्या रे? Do you know? Okay, so after taking the LCM, now it is very important, we have to take the LCM. LCM is actually P square into P plus 2 bracket cube. This is the LCM of right side. There are 5 fractions, and out of these 5 fractions, the LCM of all these 5 fractions is P square into P plus 2 bracket cube. So we have to calculate the corresponding numerator for this LCM. Now see this, A divided by P, A divided by P. So to get the corresponding numerator with A divided by P, so reduce 1P, multiply by this A divided by P to the LCM. But the LCM no multiply kara pratyek factor la, we will get the corresponding numerator. Now this is the LCM. So see this, P square into P plus 2 bracket cube. This is LCM, so we have to take corresponding numerator with A divided by P. So this P get cancelled with P square. So remaining term is P in a bracket P plus 2 bracket cube. So remaining term in the numerator is P in a bracket P plus 2 bracket cube. Is it okay? Now secondly, again we have to multiply by second factor. LCM is P plus 2 bracket cube into P square. This is LCM. Now we have to calculate the corresponding numerator for second fraction. The second fraction is P divided by B divided by P square. This P square get cancelled. That means to obtain the corresponding numerator, we have to multiply each fraction by LCM. So we will get B into P plus 2 bracket cube. लक्षात येतं? मग C divided by P plus 2. मग परत आता LCM ला काय करा पहा, या LCM ला मल्टिप्लाय करा. कशाने मल्टिप्लाय करणार आहोत आपण? थर्ड फॅक्टर C divided by P plus 2. So this bracket will be get cancelled with the bracket cube. Then remaining term will be C into P square into P plus 2 bracket square. So P square into P plus bracket square. P plus 2 bracket square. In this way we can obtain the solution. बरोबर आहे का? पहा बरे, ठीक आहे. मग आता परत इथं D न मल्टिप्लाय करा. So we will get the result as in this way and we can obtain the solution. Now our aim is to reduce one bracket. Now our aim is to, from this equation 2 we have to calculate the values of A, B, C. How we can get? Okay, बरोबर आहे प्रणाली मेरी मोरे, very good. Now how we will get the value? If we put P is equals to -2, because if we put P is equals to -2, then what will happen? This term will be goes to 0, this term will be goes to 0, this term will be goes to 0, this term will be goes to 0. Means 4 term will be goes to 0. We can find the value of EP E easily. So first of all we have selected, put P is equals to -2, then we get the value A0, B0, C0, D0, E into 2 square. P means 4. So here is a -1, -1 by 4. In this way we can obtain the value of E is equals to -1 by 4. This is 1. Again, if we put P is equals to 0, then what will happen? If we put P is equals to 0, then A goes to 0, C goes to 0, B will be 0, D will be 0, E will be 0. Then by putting P is equals to 0, which constant we can calculate? Student, tell me. If we put P is equals to 0, then which constant we can find? See here, if we put P is equals to 0, then it is possible to find the value of B only directly. So here we have to put P is equals to 0. We will get the value of B is equals to 8. Now see this, there are only two factors here, p and p plus 2. So we can put p is equals to 0 and p is equals to minus 2, then that brackets will be goes to 0 and we can find the constant. But after here we can't change any bracket 0. We can't change any bracket 0. So hereafter we have to put any smallest value of p. So by putting p is equals to 1, these are the considered value. You can put any value, but for the easily calculation it is convenient to put smallest value of p. So if we put p is equals to 1, p is equals to minus 1, p is equals to 2 in equation 2, then we will get the equation in terms of ACD. We will get three equations in terms of ACD, and by simultaneous solution of these three linear equations, then we will get the values of ACD. A is equals to minus 1 by 16, C is equals to plus 1 by 16, and D is equals to 0. You can solve this in the rough because this is the same calculation part. So I have removed this calculation part, because if we want to calculate, if we put p is equals to 1, p is equals to minus 1, p is equals to 2 in equation 2, then we will get the equation in terms of ACD. Because b is already known, its value is 1 by 8, e is already known, its value is minus 1 by 4. So put that values, then there is a three simultaneous equations. There will be the three simultaneous equations, A, first, second, third, which includes ACD, and by solving this simultaneous equation, we will get A is equals to minus 1 by 16, C is equals to 16, D is equals to 0. Thus, we have value of A, B, C, D, E. A is minus 1 by 16, B is 1 by 8, C is equals to plus 1 by 16, D is equals to 0, E is equals to minus 1 by 4. So put these values, all these values in equation 1 and calculate its inverse Laplace transformation by taking the partial fraction. So inverse Laplace transform of this, inverse Laplace transform of left side, which is equals to inverse Laplace transform of right side, and here right side is in the partial fraction form, and whose numerator, by putting A is equals to minus 1 by 16, putting A is equals to minus 1 by 16, B is equals to 1 by 8, C is equals to 1 by 16, D is equals to 0, and E is equals to minus 1 by 4. By putting these values, we can write the complicated function into the addition subtraction form of a simple function. Okay. Now our aim is to solve the inverse Laplace transform on right side. So keep this minus 1 by 16 out of this L inverse. So minus 1 by 16 L inverse of 1 upon P. Again 1 by 8 you can take out of L inverse, the 1 by 8 L inverse of 1 upon P square, plus 1 by 16 minus L inverse of 1 upon P plus 2, minus this goes to 0. See this goes to total term 0. So it is not necessary to write it again. And again you take minus 1 by 4 out of L inverse. So 1 minus 1 by 4 L inverse of P plus 2 bracket cube. Here is a cube. Okay. It's a cube I paha. P plus 2 bracket cube in this way. Now you can use the property of inverse Laplace transform. So minus 1 by 16 inverse Laplace transform of 1 upon P is 1. So we have written 1. Again 1 by 8 L inverse of 1 upon P square is equals to T plus 1 by 16 e raised to L inverse of P plus 2, in here A is 2, so e raised to minus AT means e raised to 2t minus 1 by 4. Here we have to use the shifting property. See this, L inverse of 1 upon P plus 2 bracket cube. Okay, and this minus 1 by 4 as it is. I am going to solve the last term of inverse function. So minus 1 by 4. First of all, we have to use the first shifting property. 1 upon L inverse of capital F of L inverse of f of p minus a means we can write this as, how we can write, e raised to minus at, a means 2t into, how we can write? We can write 1 upon p cube, capital F of p. So this we can write 1 upon p cube, capital F of p. And again, L inverse of 1 upon p cube is equals to t square divided by 2 factorial. This is the L inverse of this, and this is the final answer. In this way, we can obtain the solution of this Laplace transformation. Okay, this problem is important problem. This problem may ask for 8 marks or 10 marks, so you have to write all these things. But here in this case, you have to solve this as like assignment or in the rough, how we can calculate this. If you don't know how to calculate the values of remaining ACD, then you can ask me, I will tell you. Okay, now next we shall move towards the problems again. Find L inverse of log of 1 plus p square. Actually, we have given here logarithmic function. So if logarithmic functions are arrived, then first of all you have to calculate, we have to solve that logarithmic function separately. We can't take directly L inverse of log, because there is no any formula, no any direct conversion in the inverse Laplace transformation. There is no any conversion in the logarithm. See this, there is no any formula in the logarithm, Laplace transformation or inverse Laplace transform. So our aim is to solve such types of problems by the method of reducing log. So first of all, we have to reduce this log. So capital F of p is equals to log of 1 plus 1 upon p square. Taking a LCM, log of p square plus 1 divided by p square. So log of p square plus 1 minus log of p square, f of p. Now by differentiating this, differentiating with respect to p, so we can write f dash of p is equals to 1 upon p square plus 1. वैष्णवी कुलकर्णी, वैभवी कुलकर्णी, संध्या केंद्रे, मध्येच आता कशाला येतात तुम्ही? तुम्हाला किती वेळा सांगितलं रेग्युलर टाइम बरोबर असतानाच यायचं म्हणून. So differentiate this, log of p square plus 1, derivative of log of f of x is 1 upon f of x divided by f dash of x. This is the derivative of logarithmic function. So log of p square plus 1, derivative of log is 1 upon p square plus 1, again derivative of p square plus 1 is 2p. Similarly, log of p square means 1 upon p square, this is the derivative of log, and again derivative of p square is 2p. So 2p divided by p square plus 1 minus 2 divided by p. Now taking L inverse on both sides by applying the inverse transformation. So therefore, by applying the inverse Laplace inverse transformation on both sides, so L inverse of f dash of p is equals to L inverse of 2p divided by p square plus 1 minus 2 divided by p. Separate this, L inverse of 2p divided by p square plus 1 minus L inverse of 2 divided by p. But here, keep these two as it is. L inverse of p divided by p square plus 1 means cos t, because here a is 1. And L inverse of 2 divided by p, keep 2 as it is. L inverse of 1 upon p is equals to 1. So we can write this. This is the L inverse of f dash of p. Now student, the turning step is very important here. This is L inverse of f dash of p is equals to this. But actually what we have to calculate? Actually we have to calculate L inverse of this term, log of 1 plus p square, but we have considered that term as a f of p. So actually we have to calculate L inverse of f of p, because we have considered L inverse of f of p. because log of 1 plus p square we have considered capital F of p. So actually we have to calculate L inverse of F of p. So for this purpose, here we have calculated L inverse of F dash of p. Now how we can write this here? Actually we have one formula. What is that formula? See this. What is that formula? L of t raised to n into F of t. Who can tell me what is the formula for this? Actually basic formula. So we can write minus 1 raised to n, okay, minus 1 raised to n d by dp of t raised to n, 1 minute, into t raised to n into d by dp of capital F of p. Do you understand this? Do you know this formula? Okay. Now if we put n is equals to 1, then what will happen? L is equals to, see this, what will happen? L is equals to L of t into F of t, which is equals to, here n is 1, so minus 1, t raised to 1 means t, and d, here d raised to n by dp raised to n. Actually the basic formula is d raised to n by dp raised to n. So n is 1, so we can write d by dp of f of p, and d by dp of f of p means actually f dash of p. Okay, so again we can write this L into L of t into f of t, t into f of t, which is equals to, इथं नहीं है, 1 मिनिट रे, t रेस टू n नहीं है, फॉर्म्युला मी थोडं चेंज करतो, 1 मिनिट, परत मी थोडं फॉर्म्युला डबल लिहितो इथं, एकच मिनिट, फॉर्म्युला थोडं रॉंग होत आहे. Now actually we know, actually this is our result. This is our result. Now how we can calculate, how we have to convert this? Actually we know that L of t raised to n into f of t. काय येतो रे फॉर्म्युला सांगा बरं स्टुडंट. So it will be minus 1 raised to n dn by dp raised to n capital F of p. Is it okay? So if you put L is equals to 1, n is equals to 1, then t into f of t, which will be minus 1 into dp by d by dp of f of p means f dash of p, first order derivative. Now if we take the inverse Laplace transformation, if we take this minus on left side and inverse Laplace transformation, so L inverse of f dash of p, we can write t into f of t, and we have to take this minus on left side, so we will get this important result, L inverse of f dash of p is equals to minus t into f of t. So we have written here directly L inverse of f dash of p is equals to minus t into f of t. Okay, so here now we have to transfer this. Now transfer this. Now transfer this minus t on right side. So what will get? L inverse of f dash of p, which is equals to f of t, which is equals to minus 2 divided by t into cos of t minus 1. But we know that the basic formula, if L of f of t is equals to capital F of p, this implies that according to the definition of the inverse function, L inverse of capital F of P, which is equals to L inverse of capital F of P, which is equals to small f of t. So here we can write again small f of t means L inverse of capital F of P, and this take minus common and you can convert this into the plus, but multiply by minus in the bracket. So our final result will be 2 divided by t into 1 minus cos t. स्टुडंट हे समजलं का रे? हे टर्निंग स्टेप समजल्या का इथून? कारण L inverse of f dash of p we have calculated, but we need L inverse of f of p, so we have to reduce this f dash of p by using this basic conversion, by using this basic transformation. So L inverse of f dash of p we can write directly minus t into small f of t, or we can also write minus t into L inverse of capital F of p. We can also write here also here. We can write here also minus t into L inverse of capital F of p. You can write directly also. So we will get this. This is the basic relation. Now thus we can calculate the solution. समझ में आया क्या रे students? Do you understand this? Okay, Shubhangi. Right, Rajmani Shubhangi. Now next problem, the same problem in this way. Now find L inverse of log of p minus a divided by p plus b. Suppose that this is a capital F of p we have considered. Let capital F of p is equals to log of p minus a divided by p minus b. Log of p minus a minus log of p minus b. After differentiation, f dash of p is equals to 1 upon p minus a minus 1 upon p minus b. So L inverse of f dash of p is equals to L inverse of 1 upon p minus a into L inverse of 1 upon p minus b. Here is f dash of p after differentiation on right side and left side. Now we have to take the inverse, Laplace inverse transform on both side. So L inverse of f dash of p is equals to L inverse of 1 upon p minus a, L inverse of 1 upon p minus b. Now L inverse of 1 upon p minus a is e raised to at. 1 upon p minus b is 1 upon bt. But I have given that formula here. We know that. What is that? Actually, we have seen it. L inverse of f dash of p, we can write t into small f of t. But again, by the definition, minus t into f of t. Again, by the definition, f of t we can write as L inverse of capital F of p. So you can use any formula. So we will get L inverse of f dash of p means minus t into small f of t, which is equals to e raised to at minus e raised to bt. So transfer this minus t on left side. So minus e raised to at minus e raised to bt upon t. Remaining term is f of t as it is, but small f of t means L inverse of capital F of p. Okay. So thus we will get this result 18. L inverse of log of p plus 1 divided by p minus 1. Capital F of p is equals to log of p minus 1 divided by p plus 1 divided by p minus 1. Log of p plus 1 minus log of p minus 1. So f dash of p is equals to, after differentiation, we will get 1 upon p plus 1 minus 1 upon p minus 1. Now taking inverse Laplace transform on both sides. So L inverse of f dash of p minus L inverse of 1 upon p plus 1, 1 upon p minus 1. So this is the same process. So you can calculate, you can convert this. Now we shall move towards the next problem. This is very important problems here. Okay, now see this. What is this here? L inverse of e raised to minus 1 upon s divided by s raised to 1 by 2. S means p. See here. Some books always uses s, some of the books we can use p. So you can put in place of s, you can put p. So we will get L inverse of e raised to minus 1 upon p divided by p raised to 1 by 2, and which is given cos 2 root t divided by root pi t. Then find L inverse of e raised to a divided by p अपॉन पी रेस टू मायनस 1 बाय 2. सर्व विद्यार्थ्यांना सूचना आहे की एस लिहू नका, तुम्ही पीच वापरा. काही पुस्तकामध्ये एस आहे, काही पुस्तकामध्ये पी आहे. एका आपल्या सिलेबसच्या बाहेरच्या पुस्तकामध्ये हा प्रॉब्लेम मला थोडा आवडला, त्यामुळे मी इकडे घेतला, परंतु आपण सर्वच एसच्या व्हॅल्यू पी कन्सिडर करा. सो एल इनवर्स ऑफ ई रेस टू मायनस ए डिवाइड बाय एस अपॉन एस रेस टू 1 बाय 2 वेअर पी इज ग्रेटर दॅन 0. गिवन दॅट L inverse of e raised to 1 by s minus 1 by s divided by s raised to 1 by 2, which is equals to cos 2 root t divided by root pi t. Again, L inverse of, we have to write this in the form of a e raised to minus 1 upon p divided by p raised to 1 by 2, means we can write in the form of a because we have to calculate this a. We have to calculate the result in terms of a. So L inverse of e raised to minus a divided by s upon s by a bracket raised to 1 by 2, which is equals to a into cos root 2. In place of t we can put at, and in the denominator again we can put at by using this formula. Yesterday we have seen that formula. L inverse of capital F of s upon a or p upon a means L inverse of capital F of p by a, which can be written as a into small f of t into at, small f of at. Already we have seen this formula. So by using this formula we can write this in place of 1 by s, a by s, and in this way we can write the solution. म्हणजे s च्या ऐवजी s by a, we have to shift s as a s by a or p as a p by a. L inverse of capital F of p, that means we have to write p by a in this way. So we will get this result. Now here in this case a raised to 1 by 2 is a constant, so we can take out of L inverse. Then remaining term is L inverse of e raised to a by s divided by s raised to 1 by 2 root a into cos of root, again root of t into a divided by, here this root a we can take out of this bracket, so root a. So a divided by root a means we can write this root a. This is the simple calculation. So L inverse of e raised to a by s divided by s raised to 1 by 2 cos 2 root t into a divided by root pi a, and thus we will get the result, complete result here, and we can see the solution. Okay, pi. Now again we shall move towards the next problem. What is that? Find L inverse of 6 divided by 2p minus 3 minus 3 plus 4p divided by 9p square minus 16 plus 8 minus 6p divided by 16p square plus 9. So our aim is to find out this Laplace transform of this. You can take 2 common from the denominator, so we will get s minus 3 by 2. Again you can take 9 common from the denominator, so it will be 9 in a bracket s square 16 by 9. We will write here 16 by 9. Here again we can take the common, here same s square minus 16 by 9 here, and separate this for both the numerator 3 for separate 3 for separate 4s. This is a simple calculation, one can calculate this. This is again separate for 8. You can take 16 common, s square by plus 9 by 16, and for second factor again you can take a 16 common, s square plus 9 by 16. So we can write 6 divided by 2 into s minus 3 by 2, 9 in a bracket, same for second, s square 16 by 9 means 4 by 3 bracket square, again 16 by 9 means 4 by 3 bracket square, 9 by 16 means 3 by 4 bracket square, again 9 by 16 means 3 by 4 bracket square. समजलं का रे? हे स्टेप्स सिंपल स्टेप्स आहेत, फक्त थोड्या स्टेप्स वाढलेले आहेत, मोठे आहेत, म्हणून हे घ्या. नाव नेक्स्ट. Okay, so we can use the separate Laplace transform. Here is 2, 6 means we get 3 upon s minus 3 by 2. Here 3 upon 9. 3 upon 9 is, and 1 we can write 3 by 9 into 3 by 4. S square minus 16, that means we can use 4 by 3 into s square minus 3 by 4 bracket square. काय केलं? Multiply by 3 by 4 and 4 by 3. Divide and multiply by 4 by 3. So we will get this s square minus 4 by 3 a square, because here is a. So multiply by a and divide by a. Or you can directly use, also you can convert. Same process for this, divide by, multiply by 3 by 4, divide by 3 by 4. So we will get this result, okay? Now you can use the formula for this. So 3 into L inverse of this minus 1 by 4 L inverse of this minus 4 by 9 L inverse of this. In this way we will get the result. So 3 as it is, L inverse of 1 upon a is 3 by 2, so e raised to at means e raised to 3 by 2t minus 1 by 4 as it is. Here a divided by p square minus a square means sine hyperbolic of 1 by 4 as it is, sine hyperbolic of 4t divided by 3, because a is 3, 4 by 3. Again this same as it is, p divided by p square minus a square means cos h inverse of 4 by 3t. In this way we will get the result. So these are the formulae which we have used here, okay? So you can easily understand this. This is the final answer for our problem, and here these are the formulae. Next we shall move towards the next problem, and this is the last problem. Find, this is actually 20 number problem. L inverse of e raised to minus, see this, L inverse of e raised to minus 5p divided by p minus 2 bracket square bracket raised to 4. This is our aim to find out the solution. So first of all we have to calculate L inverse of 1 upon p minus 2 bracket raised to 4 or s minus 2 bracket raised to 4. So how we will get? By using the shifting property, by using this property, shifting property, we can write L inverse of 1 upon p minus 2 bracket raised to 4. Here a is 2, so e raised to at. L inverse of 1 upon s raised to 4. So e raised to 2t as it is, divided by gamma 4, multiply by gamma 4. So L inverse of gamma 4 divided by s raised to 4. Then we will get, by using this formula we can write, or you can write this directly. In this way you can write also e raised to 2t into 1 upon s raised to 4 means 1 upon p raised to 4. 1 upon p raised to 4. L inverse of 1 upon p raised to 4, we can directly take the value t raised to 3 divided by 3 factorial. So you can use directly here this also. It is not necessary to divide and multiply here. You can reduce this step also. So e raised to 2t divided by t cube divided by 3 factorial. So we will get e raised to 2t divided by 6 into 2 cube factorial. This is the inverse Laplace transform of only 1 upon s minus 2 bracket raised to 4. But actually we have to calculate inverse Laplace transform of e raised to minus 5p. So again by using the translation property we get L inverse of e raised to minus 5p divided by p minus 2 bracket raised to 4 will be 1 by 6 e raised to t, means by using this transformation t minus 5. Again t means t minus 5 if t is greater than 5, and it will be 0 and it will be 0 if t is less than 5. Already we have seen this theorem. So by using this formula, we can write t can be shifted into the t minus 5. So we will get this result, and this is our final answer, that is 1 by 6 e raised to 2 into t minus 5 into t minus 5 bracket raised to 3. Here we have to put t as t minus 5. T as t minus 5 in this way. Thus we will get the solution. This is a theorem. Last step is depend on theorem which we have studied. Okay. Now students, these are the assignments. Actually this is assignment number 14. 1 minute. Actually this is assignment number 14. This is assignment number 14. Determine the inverse Laplace transform of the following. These are the same problems which are as like a previous example. So L of f of p is equals to 2 divided by 4p plus 7. These are total 8 examples you have to solve. These are the total 8 examples you have to solve, and it is possible for you also to calculate such types of problems. So again, one problem I want to give, this type of one problem I want to give. So please see this, this type of a problem, that is a 9 number, assignment number 9. Find L inverse of e raised to minus 3p divided by p minus 4 bracket raised to 5. Is it okay? Students, you can use same theorem, this theorem, for the final answer. Remaining terms are as like same. So you can calculate this example, and again one example 10. Find L inverse of log of p plus 3 divided by p minus 3. Okay, so you can calculate the answer based on this, p plus 3 divided by p minus 3, and you can solve this. Okay, समजते का? तर हे सर्वच्या सर्व प्रॉब्लेम 10 प्रॉब्लेम सर्वांनी असाइनमेंट मध्ये सोडूनच असाइनमेंट पाठवायच्या. अगोदरचे प्रॉब्लेम सॉल्व्ह करायचे, परंतु हे सर्व 10 प्रॉब्लेम, all these 10 problems you have to solve in the assignment and then send assignment on email or on in the WhatsApp group. Okay, समजतंय का? आणि कोण आहेत असाइनमेंटची प्रेझेंटी घेत असताना कदम हे 10 प्रॉब्लेम सॉल्व्ह केले असेल तरच त्यांची प्रेझेंटी घ्यायची, नाही तर घ्यायची नाही. 10 प्रॉब्लेम सॉल्व्ह केलेत का पहा आणि मग त्यांची प्रेझेंटी घ्या. ओके, हे सर्व प्रॉब्लेम्स आपण प्रिव्हियस ज्या पद्धतीने सोडवलेले आहेत ना, त्याच पद्धतीचे प्रॉब्लेम्स आहेत. हे काही वेगळे प्रॉब्लेम्स नाहीत, फक्त तुम्हाला चांगल्या पद्धतीने हे सोडवता आले पाहिजे, हेच इथं अपेक्षा आहे. ठीक आहे, चालतंय का रे? मग थांबायचं का इथं? ओके, सो वी शॅल स्टॉप हिअर. थँक यू. राईट, ओके. तुम्हाला जर काही अडचण आली, काही जरी प्रॉब्लेम आला ना, तर तुम्ही मला विचारू शकता. ओके, हे 10 प्रॉब्लेम्स लिहून घेतलात का रे सर्वांनी? हे 10 प्रॉब्लेम लिहिलात ना? ओके, नाउ वी शॅल स्टॉप हिअर. इफ यू हॅव एनी डाउट, देन यू कॅन आस्क.